Target B. This is using properties of rational and irrational numbers. Number 1, says click on two numbers whose sum is addition. When added, would be irrational. So remember, irrational numbers are numbers cannot be written in fraction form. And has non-repeating decimal. The opposite, rational, is repeating decimal. Repeating decimal numbers are fractions, or can be simplified as a fraction. So the trick in doing these problems is just labeling each of these numbers. To remember, if there's a sum, irrational plus rational is irrational, I plus I equals I. So let's label each one. We know -5 is a rational number because it can be written as a fraction. 3 square root 2, we know that square root of 2 cannot be simplified, so this is going to be irrational. 2/3, that's clearly a fraction, that's a rational. 1/3 rational square root of 8, you cannot simplify, you cannot get a whole number from it, so you get irrational. So same thing at the bottom, these are the same exact numbers, so I'm not gonna reinvent the wheel here. Square root of 7, again, you cannot simplify it further, so it's going to be irrational. So to add, we're going to add two numbers, so we need an irrational and rational. Make sure you're reading the instructions correctly. It says only 2, shade, in this case shade 2. So we want an irrational plus rational, so I'm going to be shading irrational plus rational. There's a lot of combinations here as long as it satisfies our rule. Okay, next one is, now we want it to be two rational numbers. So in order to be rational, they both have to be rational. So I'm going to go ahead and choose the first and the third. That's it. Okay, next, these are the same numbers. So I'm just going to rewrite everything here. Rational, irrational, rational. Okay. So we got two numbers whose product, so it says product is multiplication, would be irrational. So right here is I times I can sometimes be rational, but the easiest route here is that if it's rational, something's rational or irrational, we're looking for irrational. So, or it could be irrational times rational. So our easier route is irrational times rational. So I'm going to be shading rational times irrational is irrational. Next, it's asking for two numbers. The product is rational. So we want rational times rational. So rational times rational. That's it. Here we go. This is the same thing. Just going by the rules here. Let's label them first. I already have the first one labeled. We have an irrational plus rational, which is irrational. Next one, we have square root of 4. This is actually 2, so this is rational plus irrational. So that's rational, rational plus rational. Rational, square root of 10 cannot be simplified. So that is irrational, so R plus I is irrational. Next is So this is like a times table. So this right here goes with this one, this goes with this, right? So here, make sure you're reading the instructions correctly. We want rational only, whose sum is irrational. So that's plus addition. So if we try 4 plus 4, that is rational. So remember, when you're dealing with rational, irrational numbers, go ahead and just label it. So this is rational, rational. This is irrational, irrational. Same numbers. And we know the rule is if it's r plus I, that's irrational, I plus I is irrational. So let's get rid of all the irrational numbers because we don't need them in this case, especially for addition, because we only want rationals. So rational, 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 and so on. So that is how you do this problem. Okay, I cross these out because they're irrational. I can't get a rational number if I add an irrational number to it. So those irrational numbers are unnecessary for this problem. Next is this problem here. Again, we do the same thing. This is irrational. Square root of 7 cannot be simplified. Irrational times rational is irrational. This is square root of 2. This is 2 times 7, so that's rational times rational is rational. Again, r times r is rational. Rational times irrational is irrational. Now here, same thing. Now we have product. So let's label our table here. Rational, rational. So this is 16. That is a rational number. So I would shade this. I would check this box. Check a rational times rational. Right here. So rational, 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 right here. Now how about this? We know that rational times irrational, we can't do that. No, we can't. But how about square root of 3 times square root of 3? So square root of 3 times square root of 3, that is square root of 3 times 3, which is square root of 9, which is positive 3. Therefore, we actually check this box off. Check this box off right here because it ends up as a rational number. How about square root of 3 times negative square root of 3? Same thing here. If I multiply by the same square root, they end up being just a whole number. So this is checked off, checked off, checked off. Okay, remember when you're multiplying radicals, they must have the same index. If they have the same index, you can multiply the radicands. Okay. Next, I saw some of you guys doing this one. A lot of you guys have it blank, which shouldn't be. All you're doing is multiplying this number so that it's a rational number. So I'm multiplying this to first, second, third. So I'm going to multiply it here. I have a rational times irrational. That's irrational. So I'm not doing that. 7 square root of 5 times 7 square root of 5. So this, they have the same index. So I'm going to be multiplying these two here. So that's 7 square root of 125 times 5. You know, 125, 5 times 5 times 25. 5, 5. I have 4 5s. 7 square root of 1, 2, 3, 4. My index is 2, so I box 2 of them. I end up with 7 times 25. Rational times rational is indeed rational, so I'm going to choose B. Number 2, parentheses here, I'm going to multiply 7 square root of 5 for each one. In this case, so make sure you distribute to both sides. So that's 5 Actually, before we even do that, before we do this distribution, let's remember our rule. So rational plus irrational, that's irrational times irrational here. So we do have to distribute. So distribute here and here. So 7 square root of 5. So 7 times 5 times square root of 5. I think that'll confuse you guys. So let me do this backwards. 5 times 7 square root of 5 plus 7 square root of 5 times square root of 5. So whenever we have two identical square roots, this just becomes 1/5 without the radical. So this is 35 plus square root of, 35 square root of 5 plus 5. We have irrational plus rational, which is irrational, so not C. Okay, if you need to slow down, if you don't understand, go back and rewatch this section again, or make it slower. So now we're going to multiply it to here, times 7 square root of 5. We're going to multiply the numbers first. 7 times 3, which is 21. They have the same index, so I'm going to multiply them on their same radical. Oopsies. 9 over 5 times 5. Remember, it's over 1. These two cancel out. Now I'm left with square root of 9, which is 3. 21 times 3. Rational times rational is rational. Okay, that's it. I think we did this earlier, but now it's just a combination. This is irrational plus rational, irrational. Rational times rational is rational. This is 2, so that's rational times rational. Now this is identical. I multiply the numbers first. So negative 100 times square root of 10 times square root of 10. Remember, if they are identical, just put a whole number without the radical. So that's a rational times rational, which is rational. So multiplication, you can rearrange the numbers. And I think that's it. All right, if you have any questions, please let me know.